In this video, we'll write the balanced net ionic equation for HBr plus KOH. This is a neutralization reaction. We have an acid and a base. We get a salt and water. And when we write the net ionic equation, the first thing we need to do is balance this molecular equation. This is our molecular equation. And it's already balanced. So that's done. Next, we need to write the states. So to do that, you need to know that HBr, that's a strong acid. And we could know that pretty much by memorizing it. So here's a chart of strong acids and strong bases that probably isn't a bad idea to memorize. We go down, HBr is right here. Hydrobromic acid, strong acid. That means it's going to break apart, dissociate into its ions completely. So we'll write AQ. It's going to be aqueous, dissolved, dissociated into ions. KOH, that is a strong base. So it will also dissociate into its ions. We can write a little AQ. For KBr, if you know your solubility rules, potassium, that's a group 1 element. So those, when they form bonds, salts here, will be soluble. And the same with Br. Those form soluble compounds. So because they're soluble, we write AQ, dissolved in water, and then water itself is a liquid. So we have the states. Now that we have the states for each substance, we can split the strong electrolytes into their ions. That's going to be the complete ionic equation. Sometimes this is called the total ionic equation as well. So hydrogen is in group 1 on the periodic table. That has a 1 plus. Bromine, that's a negative charge. So we'll write H plus, and I'll write aqueous at the end. I won't write that right now, plus the Br minus. Potassium group 1, and then the hydroxide, that's a polyatomic ion that's always negative. So we have K plus the hydroxide there, plus OH minus. So those are the reactants. Let's do the products. K we said was plus, minus, and then water, we don't worry about. That's not going to dissolve or dissociate. It stays a liquid. So we have K plus here in the products, plus Br minus, and then plus that liquid water, H2O. So this is the total or complete ionic equation. Now we can cross out these spectator ions. Spectator ions, they're on both sides of the equation, in the reactants and in the products. In essence, they don't change, so we're not interested in them. So here I have a potassium ion in the reactants and in the products. Let's just cross it out. I have bromide ion right here, and then in the reactants, cross it out. But everything else is unique, and that means it's the net ionic equation. We have H plus, OH minus, and we end up with H2O. So let me clean this up and write the states in, and then we'll have the net ionic equation for HBr plus KOH. So this is the balanced net ionic equation for hydrobromic acid plus potassium hydroxide. You'll note the charges are conserved. We have a plus and a minus, and it's neutral on this side. And we have the same number of atoms on each side, 2 hydrogens on both sides and 1 oxygen. This is Dr. B with the balanced net ionic equation for HBr plus KOH. Thanks for watching.